All right, we are ready to get started with our final session for today. Our session will be led by Hussein Syed. He is the Chief Information Security Officer at RWJBarnabas Health. It is an integrated healthcare delivery network in New Jersey. He is responsible for the organization's information security program. Hussein and his team are responsible for security management planning and execution to align with the strategic goals of the health system. He has more than 25 years of experience in IT, of which 17 years are in information security. He has spoken at RSA, HIMSS, Gartner, NJ HIMSS, TCG events, and participated in other security-related events. Please welcome Hussein Syed for his talk on AI and ML use in cybersecurity.
Thank you. Last session of the day, so after this is probably drinking. So I am by no means an expert in ML or AI. I'm just going to take a stab at it, see what we can talk about. The opinions are, of course, my own, not of my employer. We're not an ML AI shop. We're a health system. We deliver patient care. What I'm going to talk about is briefly about, what I see as AI and ML to be, and how can we use that in information security, and how to build a business case to get a solution that could be of AI ML based. Artificial intelligence, machine learning. The way I look at it is, artificial intelligence, it's really a cognitive function related to human minds, trying to be able to do the things that beings can perceive, do, and do it in a larger scale. Because of the shortage of resources, shortage of expertise, you can't really expect everybody within the security paradigm to be able to do the things that AI can do. Now, taking it further, ML is really algorithms that can be used to detect patterns, behaviors that can be used for figuring out what happened or what can happen, and then more advanced, which is typically used in medical research and large-scale, dark web analysis, what the recommendation, what the predictions can be. Three basic types of analytics, descriptive analytics, predictive, and prescriptive. In my opinion, most of it is usually descriptive. What really happened in a SOC environment. How did this breach take place? How did this incident happen? How did the malware get into your environment? How did somebody make that mistake maliciously or inadvertently? What really happened? And then your predictive analysis or analytics, where probability of what will be happening, what can happen based on the data you have gathered, data-driven. And then, prescriptive analytics, which is really used in e-discovery and other larger data sets. And that's where really the benefit of machine learning comes in. You can utilize that to make decisions because humans in itself, have limited thinking because of the shortage of resources. How does the machine learning work? There are three basic types of machine learning. You have your supervised learning, algorithms that take instructions from humans. They'll make decisions, and then humans have more input into it, figure out how to get the right output, because in supervised learning, output is predetermined. If it's a breach, if it's an incident, if it's some kind of a misbehavior on a system, you know what you're looking to see. You're just trying to detect how it happened. That's sort of supervised learning. Unsupervised learning, basically, you don't know what the output could be. You let the machine give you some patterns, use that to go back to supervised learning, then get back some output, enrich it with more data, find other data sources, put it in, let it churn, and then give you that output. And reinforcement learning, as you can see, it's really, to perform the task at a massive scale. You could have lots of data. Now, the bigger pitfall with all this is you got to have a lot of horsepower, a lot of memory, a lot of processing, so that you can conduct those and get the fruitful results back. Deep learning, sets on a wider range of data, requires less data pre-processing by humans. You kind of know what you want, when you get to this stage. You got to have some sort of a data scientist on staff, which most organizations don't. So I'll explain further why we use commercial tools as opposed to building AI ML tools in-house for security. We do that for medical analytics because that's where we are. But for security use cases, we typically use commercial products. But we have a process of figuring out what the product does and how it'll fit our use case. Often accurate results, the way algorithms work, the calculators, there's complex things that happen in deep machine learning. But that's what you will use to determine what product you would select. So I wanted to kind of hone in on the tagline. I stole that from McKinsey, really. Convergence of algorithm advances, data proliferation, and tremendous increase in compute power that's available out there. You can spin up an AI instance or a cloud instance at Amazon or Azure and do what you need to do and then shut it down and move forward. So that's really what's driving most of the AI development. Use cases in security are usually user access monitoring or security operations. That's what we typically use it for. I go a little bit of detail in how we do it. So security access monitoring or system access monitoring is really a regulatory requirement in healthcare environments because of the HIPAA regulations. Healthcare is a very complicated set of systems that communicate back and forth through either an integrated data system or through some sort of a data feed that's called HL7, meaning one system will send data to another system. That system will do whatever it needs to do. People will log in and send data back. An example would be you walk into a hospital, you're going to a registration system. That's where you get registered to be treated at that facility, provide your information, your insurance information. You've been registered into the hospital. You get sent over to ER for any type of diagnostic work. That's an EHR. That's where all the clinicians will make their notes. If you need to get any testing done, that system will send an HL7 feed to a lab system where they will get the data up. You'll provide your samples. You'll get your testing done. The radiologist will update information into the lab system. Lab system will send data back to the EHR. That's where the physician who's actually treating you will look up and say, all right, the blood test came back with high cholesterol or whatnot, right? So that's how all the communication happens. But behind the scenes, users are accessing all that data, all those systems. And it all has to be audit logged and then put into some sort of a system so that proactive monitoring can be done so that to ensure that people are only accessing the information they need to access, nothing more, nothing less. And that's where we looked at using an AI-based solution because the amount of information we capture in all those systems, it's humanly inconceivable to actually review all the data and be able to make sure that every patient's information is properly accessed. So we focus on high-risk events, not all the events. Our goal was to reduce the human workload and only take the actionable items that we will analyze and then send them over to the respective departments to investigate. We picked a product called Protenus. It uses supervised learning algorithm of random forest. It's a supervised learning in the sense that a data scientist will have to work with our clinicians in order to determine what is the good use of the system and what is the bad use of the system. How would we understand whether somebody in their regular course of action or is accessing a patient's information when they should not be accessing, or are they accessing when they should be accessing? And that's where we felt that ML and AI would play a big role. It incorporated feedback from our privacy officers, our clinicians, our nurses, our nursing managers, security folks, to make sure that we only qualify the incidents that we need to review and take further action on. Give you an example. in a basic or in traditional use case, you would be looking at to investigate in unauthorized access of a system by saying, where do you live, or where does the clinician live, what zip codes are, and what street address it, or do they work there or they don't work there. You will take all that, and it turns out if you have a large enterprise and people from that locale are coming to their hospital, chances are the people who work there also live in the same neighborhoods, and the people who are being treated there live in the same neighborhood. So you will get a whole lot of incidents that are, upon investigation by humans, would become to be false positive. So you really need to look at the behavior, at the trends, at the data patterns. So, and that's where AI or ML would come in to do modeling and learning by the system to make sure that this clinician accesses all these patients during the course of the day. And they may be providing some consultative services at other departments in the hospital too. So what would be the abnormal behavior of that clinician if they were looking at somebody's information that they weren't supposed to look at? And that would create all the ML has created all the threat models that we've been using. So we went from about 1,000 incidents to 100 that we needed to look at, out of which then we further qualified to be maybe 5 or 10 per month that we needed to really investigate that would be considered abnormal activity by the clinician or anybody working at the hospital. So taking 1,000 to 100 to about 10, 15, which are manageable. The other thing we looked at this algorithm was, how can it explain? So all this audit log data, complex data goes into this system, but it has to be reverse engineered so that you can actually at some point sit down and talk to somebody and say, this is the way you access the system. These are the data points we looked at. And so you have to be able to do forward engineering and backward engineering, and that's what random forest algorithm and supervised learning does. The other thing we needed to have is robustness. And that was really around overfitting, which it really means that once it's trained on a certain pattern, it should be able to use the same training to look at a smaller data set and determine the same result. So if a new patient came in and it was a VIP or was a celebrity, there will be a very small amount of clinical data about that person. But the system should be able to identify and alert on some abnormal or wrongful access or unauthorized access for that patient. And that's what this algorithm does. So that's how we selected this. On the security and operations, the two use cases we have are basically threat intelligence and user behavior. In the threat intelligence, we partnered with IBM. So the Watson Advisor really is an extension of IBM QRadar product. It's integrated into it. What we do is we get logs from about 100 type of systems. And there are about 1,000 systems, but there are 100 types of systems like firewalls, IDS, endpoint, everything else. It all goes into our QRadar system. And then we also take some sanitized data that's coming from our HR and other systems. We obfuscate all PII information, of course. We tokenize a bunch of data so that we're making sure that we're not infringing on anybody's privacy. It takes that data, it processes it internally, then it qualifies what's called offenses internally. And then it actually uploads or queries the ML-based system that Watson Advisor has. And it actually looks at the data it's seeing outside on the dark web for that type of an offense, any type of heuristics, indicators of compromise, and whatever else, and comes back and it gives us a narrower set of information that we need to react on, and actually gives us a lot more we can do with a shorter number of folks. So we have about 6 or 7 SOC analysts for an enterprise that runs about 13 hospitals, about 60 to 70,000 endpoints, lots of servers, a lot of data going back and forth. So this helps us kind of crunch it all down to a manageable level. So we take the data from QRadar, we have that offense. That's still not good enough for us because we still have larger set of incidents that we need to deal with. So what we do is we partner with Recorded Future. Recorded Future is another threat intel provider that curates a whole lot of threat data from the dark web, takes our incident, and now we're able to look at that data and say, is there anything else happening on the dark web related to that incident? How should we risk score it? Is it risk-based 1 or is it risk score 10? Depending on where it falls, that's when we take the action. Some are automated actions, some require human intervention. The SOC analyst has to engage the IT folks or the user itself to find out what really happened. And that's where we use the Recorded Future solution. It creates a fairly good roadmap for us from that perspective because we're able to do lots of things with a fewer number of people. And we bring in quite a few interns, we train them on these systems, and then we're able to use them for a period of a year so that they can be productive, and then they leave and seek employment elsewhere. The training the models within X-Force. X-Force is a threat feed that we get from IBM as part of our QRadar. And as you can see, there's a whole lot of stuff and a whole lot of information it looks at, a whole lot of data it pulls through that as a SOC analyst or folks would not be able to do. So that's where we feel the value of machine learning and AI comes into play. For an average organization, it's not easy to hire a data scientist. First of all, they're so expensive to hire. If you can find a good data scientist. You can teach a SOC analyst a little bit of Python, a little bit of R, so they can do some of the work. But when it comes down to really looking at this data and creating these threat models and training your data set to be able to do something, you really need a partner, a company that has invested into this, this space and is actually willing to stand by it. The other area we use it for is, user behavior analytics. This is another area that we've been really working on for the past 3 or 4 years, and we're just about making some progress. We look at about 18 attributes of a user behavior to determine what they could be doing that could be deviating from their normal course of action on a day. Their access, their time of access, is there any type of denial of service happening on their workstation or on the network? When do they authenticate? Any type of firewall information that we can see in terms of proxy logs or anything of that sort. Activity on application, whether they're moving from one system to another, that gets determined from port and network information if they're logged in from one place or the other. And that allows us to put together a fairly composite profile of a user. Here, the playbook we have currently that we've been working on are the 3 basic use cases. One's detecting users' deviation from themselves. So if they have a normal way of accessing the system, and what times they access, and what do they do. And if they start to deviate from that, then we have a reason for be concerned. It could be normal. There are times when people have to access a system at abnormal times. If they work in support, they go on call at different times. Different things happen, but that's where we need to be able to collect data for a longer period of time. And then analyzing that data in a traditional relational database way probably doesn't work right. So we have to have some sort of an ML type of a solution that it uses the right algorithm to build the right user case or the model so that we can actually see the abnormalities and look at them to be something abnormal. The other is their activity versus their frequency of access. So on a normal course of day, they access the system in a certain way, and they access a certain amount of information. Then all of a sudden, they're accessing the same systems, but the access levels have gone up. They're reading more data, they're looking up more records, or they're doing more surfing, or doing something that's not within the normal span of time. The last one was just anomalous deviation from their peer groups. So if they work in a department, say patient accounting, and they access a certain amount of information, they do a few things that are related to patient accounting, all of a sudden they have moved away from that, and now they're doing some things different. So that would raise a flag. Putting it all together, we would look to see, is this a cause of concern? Should we further investigate the employee? What else do we need to do to make sure that it's not a real threat? Here are some of the examples of how the data points that can be looked at. You can see the actual and then the learned behavior, and you can see the deviations from it. And it can be expanded over a longer period of time to give you a better graph, better distribution of what's happening. And then you can kind of pick out who you need to kind of target to investigate. And it's really the good, bad, and ugly situation. We're the good guys. There may be some bad guys, but there are lots of ugly guys, like nation states, trying to do things, infiltrate into an organization, steal somebody's identity within the environment and start using that to laterally move, do all the things that hackers do. And that's really where we have to focus on. More examples of how the risk posture, and then the activity. And here's I took out a slide around deviation from peer group. And it could be anybody. It could be a senior executive in an organization. It could be somebody in IT who has privileged access. And those are the most dangerous ones, by the way, because they tend to think they are immune to any type of malfeasance and end up being the targets. So all that putting together gives us a reasonable amount of data to be able to do things we need to do with a shorter number of or smaller number of people. Another example of how Watson helps us analyze. And then we go to get an actionable report, and actually shows you where its risk scores at. And this all is done by their trained system and their supervised system or unsupervised system. From our perspective is we really need to build that model so that we are able to utilize the data that it's generating. Business case, investigating an incident without AI. And here's the breakdown of all the points you would capture, all the information that you're collecting, and then being able to siphon through that. That's where the alert fatigue comes in. In a normal environment, you typically have about 40 to 50% of alerts go unnoticed or unacknowledged because people are so busy investigating 1 or 2 or 3 threats that they let everything else fall by the wayside. And that's where something bad can seep through all the investment that's been done, all the confidence that's been built with the organization, and something happens, and now you're standing there trying to explain why it could have happened. And I believe the AI ML-based solutions have really helped us figure that out. But again, the problem remains is how do you get the system to train to your environment? That's the key. Every environment, every organization's way of doing business is different. Every organization's data flows are different. But how do you get a adaptable solution that will be trained on your data set, that your log data will give you confidence in detecting alerts? I use this as a comparison. On a higher, it seems like all right, but when you go down to the bottom, you see with a normal human analyst, you can get about 1 million alerts a year, whereas I can't even figure out what that number is, but that's the analysis that can be done by machine learning. And it'll use a process of deductions, and it has got multiple algorithms that it'll use to get to you that data. Again, The key is your solutions should be able to cut down on human involvement. Your human resources are expensive. Once they get trained, they leave. So you got to find a way to, utilize a solution that can actually work for you. There's always human intervention needed because the intellectual property typically is with the users, with the analysts, with the subject matter experts who need to be brought in at the right time to make that decision, whether this is a qualified or non-qualified, or it's something to be discarded. Another representation of how quickly you can use a analytics tool that is backed by proper trained data to cut down on the amount of time it takes to detect a fault or an alert that needs to be investigated. So in order to kind of figure out how do you figure out what type of a solution you need, you got to start with your requirements. What is the business case you're looking to solve? Are you looking to fix a problem with behavioral analytics, or you have a SOC or a NOC and your folks are just grappling and struggling with dealing with incidents and not being able to do anything, or they're working longer hours, you're burning them out? And then document what 5 or 6 or 10 things they need to be able to accomplish by a new solution. And then pick that solution, talk to them, find out what type of algorithms they use. This is where I sort of recommend that, as a CISO, I took a couple data science classes. And the objective was just to understand how does data science work. I heard a lot of Python, R, data modeling, training data. We can take gigabytes of data and turn into this. I'm not a programmer. I could not even program in Python, but I understand just from attending the classes that what do I need to do to find the right solution for my environment. Inquire about the vendor sources. Where do they get their intelligence from? What type of data do they collect? What are those sources? Are they going to be around for a longer period of time? What is their roadmap for the product? Are they utilizing the same techniques that are talked about in data sciences? Are they descriptive, predictive, and they are going to be prescriptive? Because that's what companies like Proofpoint and others have to do to tell us the right alerts that we need to worry about. Look at the product demo, talk to the customers of your size, your environment, your problems, and then do a proof of concept. And then contractually obligate them to meet those SLAs. Put some penalties in there so that you're not signing it through a 3-year deal with a provider and your implementation is not done in 3 months or 6 months. So I think that's all I have. Any questions? Thank you.
You said that you'd been working on the user behavior analytics for a while, and I can see at least 3 challenges you have, because we're starting to try and do that as well, and that's what attributes are you looking at, what are your peer groups, and how do you identify normal? Can you comment on your development of user analytics and how you tackled those?
So we were, very naive in our approach to it. We started to think that DLP would solve our problems. And we started to look at, if somebody's accessing credit card data or social security numbers and putting that together. But as we moved forward in that, we really started to look at 3 things. The peer access is what we figure if, for example, a secretarial staff, if every secretarial staff, does some shopping for their boss, does some appointments, travel arrangements, and other things, and all of a sudden, if there are 2 that are not doing that, are doing a lot more than that, then we found at one time that one of the secretarial person was running a business from her desk because, and that department had entered a request to hire another FTE because the person wasn't able to fulfill the workload she had. And when we went through and we said, well, there is a big peer group difference. I don't know what type of responsibility this user has, but she does a lot more banking than anybody else. So it turned out she would use a scanner that had been provided for her to scan documents, to scan checks in, to pay or to deposit them because she had auto deposit. So some of those things are, but it takes a very long time, and we still come across a lot of false positives. So we tend to be very careful how we approach that. We hardly ever approach the user directly. We try to get the information about it in a subtle way, and then weigh that in, and then try to see what is a qualified. And at that point, we engage the manager or human resources to investigate it further. And many times we find that it was the position change, and that's why it's happening this way. So now we've really started focusing on two big areas: IT, because we fear if their credentials and they're compromised, it could lead into a bigger intrusion, or a financial services division, where they do a lot of coding and billing of services we offer. And we'll continue to do that.
Any other questions?
We talked about external threat indicators.
Yeah.
So have you used that effectively, or is it just learning?
So that was the main reason to go with the provider than to collect data into some sort of a data lake and start learning to do that. We use Recorded Future and IBM Watson Advisor, and they curate the information quite well. And yes. So especially in the malware analytics, it's pretty good. And we are. So I could give you an example where we had a malware come in, and it seemed like that on the surface it was a damaging or an exfiltration based malware, but when we took that into the sandbox, detonated it, took those and fed that back into QRadar and queried that against the Watson Advisor, it came back that it had the indicators that it would be an exfiltration based, but it was really just simply a damaging one. So we were able to risk assess and say, all right, we don't have a breach risk here. We have a risk here because it could be a denial of service where multiple workstations are compromised, production might be low, but in terms of breach, it would not be.
All right. Thank you so much,
Thank
Hussein.
you.
That concludes our first day. Thank you all for attending, and a special thank you to all of our speakers and sponsors.